Okay, I just gave you a new piece of pink cardstock. Hence the importance of the material, as Coach noticed. Your choice. Some people don't need to look at the green sheet. Well, I'm actually going to recommend. I would put it back to back with the green. I don't think you're going to be using this much anymore. You pretty much got that idea down. So I would just put it back to back with the green. Very quickly, raise your hand, please. What goes here? Come on. Extra. Raise your hand. What goes here? Quick. Sarah. Who agrees? Point. 2 for Sarah. This feels like a silly exercise. That means you're understanding. That's good. Please raise your hand. Go, Tori. Who agrees? Point. 2 for Tori. We could do this all day long. Raise your hand, please. What value could I put here that would result in the same value here? Just look ahead. Raise your hand if you're ready to speak. Keep your hand up if you would have said any constant. Point 2 for Josh. Okay, so it's a simple idea, but I hope that this dumb little demonstration will make the idea very permanent. That it doesn't matter what value is here. Minus 12. Plus pi. Some person last period said Planck's constant. Whatever. Avogadro's number. The age of the universe. I guess that's not a constant. Whatever, okay? Whatever. Doesn't matter. Here's the point I'm trying to make. If you start with an equation for f, and that equation for f is x squared. You take the derivative, you all know that you get an equation for f prime, and the equation for f prime is 2x. Not a big deal. However, if we want to go this direction, like this, we are going to be doing what's known as an antiderivative. Give the pen back to Lauren for just a minute. The antiderivative. Some books, some textbooks refer to an antiderivative as an integral. To me that's very confusing though, because how do I know the difference between what we've been doing, which is integration, versus this? So some textbooks, they distinguish the two by saying this is an indefinite integral, and what we've been doing for the past 6 weeks, that's a definite integral. I like the words that the AP test uses because I find them less confusing. What we have been doing is integration. What we are now doing is anti-differentiation. Okay? So we've been doing integration, that's the last 6 weeks, that was the last test. Now we're going to spend some time doing antiderivatives. Question? Awesome. So you will see those other words perhaps in other books if you go on to other classes, but for our class, we've been doing integrals, now we're going to do antiderivatives for a while. Somebody asked where we are in terms of the whole year. We have remaining one more unit, which we are starting today, and then we have a few kind of miscellaneous concepts that don't fit well into a unit. And so how we're going to handle all this is we'll study this unit, which I call integration without a calculator. Previous unit, I'm very creative when it comes to names. The previous unit was integration with a calculator. Once we get done with this unit, integration without the calculator, we will not take a unit test. It will be then time to start taking tests that cover the whole year. As we start doing tests that cover the whole year, we'll still have a few topics that we'll kind of discuss. It's not really a unit, we just kind of fit them in as we proceed forward with actual all-year testing. So it takes a while to take all the tools you have learned and figure out how they apply to actual AP tests. So we spend a lot of time doing that. Question? Please.
Like in fourth term, we're going to have a big final practice.
What we do in fourth term is a little different than a lot of classes. Is I set up a system where you take an AP practice test, and as long as I can tell by your work ethic and your determination and your dedication to get help and all that kind of stuff, that you really are working to do the best you can in each and every practice test, we're just looking for progression. And the students who do that, what happens is they just progress through it's really pretty much all of fourth term until May 5th, and we only count like the last step. Like the idea is just to show a progression. Now students who don't take it seriously, lots of their tests count because they didn't take it serious. If you take it serious and you progress, we just keep throwing away test scores. Okay, oh, the next one's better. Great, let's just count that for your grade. Does that make sense? Yeah. So it's not like we build up to a big final. It's more like I just want, each time we practice, I want to see progression. That's all. If you can't show me progression, it means you're really not doing what you need to do. Like you're not coming to get enough help, so that I can't throw it away, I just have to use the test. Questions here? Awesome. Key thing to notice. If you start with F, you can find F prime perfectly, okay? But as I was showing you here, if you start with F prime and you go this direction, antiderivative, I can't find this perfectly. The best I can do is say, if I start with 2x, maybe I started with x squared, but maybe I started with x squared minus 10. Or maybe I started with x squared plus 3, or x squared minus e. I don't really know. So you can't go backwards perfectly without some additional information. That's why there's this extra c. It just stands for whatever constant you want it to be. Like you just don't know, so you just write plus something. Question. The constant is a bit of an afterthought. Like you don't need to stress about it. It's just this idea right here that when I'm going backwards, I don't know if I had plus 7 or I had plus 0. So I just put the plus c to remind myself of I don't know what it is yet. So it could be 0. Question. Awesome. Next big thing. Rule sheet. Okay. A couple of key differences between the antiderivative rules and the green derivative rules. First key difference. The derivative rules are generic. If you look at the green sheet, it has things like, g to the, g of x to the n power, meaning the g of x could be who knows what. This does not have that flexibility. It is just x to the n. So if the formula you're trying to find the antiderivative of isn't x to the n, you cannot use the rule. Like I can't look at my rule sheet and say, this says x to the n. So if I have x squared, great, it works. If I have sine squared, it doesn't work. On the green sheet, you can still get it to work because it's g of x squared. And g of x could be sine. Just wait if you need me to repeat that again. So the good news is, on the green sheet, you had to think in a very flexible way. On the pink sheet, you don't. You just look at it and say, do I have x to the third? Great, I can do it. X to the minus fourth, that works fine. If I have sine to the fourth power, it doesn't work. Okay? Anybody else need to talk more? Just wait. So on the pink sheet, very, very specific. Other good news. For our class, we studied derivatives quite thoroughly. We spent a good amount of time studying that. For antiderivatives, we study them very much less. The heavy study of antiderivatives occur in the next calculus class, not this one. So comparing to BYU, this is Math 112, similar at least. You'd have to take Math 113, which is the next class. Okay? At this school, that would be like if you're taking BC, they study antiderivatives heavily, we just don't. Okay? In fact, we will only find antiderivatives by using what you see here on the pink sheet, or there's a couple of other techniques we use that we'll talk about in the next day or so. But ultimately, you're still always using one of these. It's just always a rule. So, next good news. On the green sheet, there were 18 different formulas you had to memorize. On this sheet, there are actually only 5. You memorize 5 really, really simple formulas, and then you memorize a trick. So the 5 formulas are on the left side of the page. To get to the right side of the page, you just have to notice the trick. Here's the trick. This says x to the n. Notice over here. It says ax plus b to the n. This says e to the x. This says e to the ax plus b. 1 over x, 1 over ax plus b. You see the trick so far. Okay, look at the second half. This says x to the n plus 1. This says ax plus b to the n plus 1. All I'm doing is wherever there's an x, I'm just putting in ax plus b. So the first part of the trick is just to get from this side, this side of the rule to this side of the rule. You just take wherever you have an x and you put in an ax plus b. The only extra is you end up with a 1 over a multiplier as well. So I don't memorize these formulas. I memorize these, and I memorize the trick to get to these. We need to talk through that again. Cool. All right, let's start. Oh, and note here, this rule does not work if n has a value of -1.
Just that value.
Right, because x to the -1 is the same thing as 1 over x. So you're going to jump down here. So it's not a big deal. Just notice if it's x to the -1, you just jump from here. Same thing here, Josh. If this is ax plus b to the -1, you're just going to jump to here. If this exponent is a positive 1, this rule actually does work, but it becomes cumbersome. There's an easier way, and I'll just show you the easier way. So I don't ever use this if x if the n is 1. So you need to repeat any of that. Okay, let's practice. Chris was correct. He said we're back to the classics. So one sheet homework, you don't write anything on this. You take out your notebook and you do your work in your notebook. Good notation, proper use of the equal sign, straight down the page. Okay. Make sure you write down the problem. These are very, very short problems. It takes you an extra 12 seconds on average to write down the problem and then do the work. I promise, if you write down the problem and then do the work, you will memorize far more quickly how to do this. When your brain can see the problem and you can see how the problem gets solved, your memory is much better than if you're like looking back and forth. So just write down the problem first. You don't have to do the problems in order. We're going to jump around in class, so don't worry about the order. Just follow me. Here we go. Okay, write down number 1, please. There's a property of antiderivatives, which is equivalent to a property of derivatives. So the good news is you don't have to really learn something new. So just look at this and raise your hand and tell me, what is your intuition telling you we should do with the 5? Just hands up. Think of derivatives. How do we treat a multiplying constant when we are finding the derivative of something? The rule is exactly the same. So how do we treat a multiplying constant for finding the derivative of something? Elaine? Just take it out. So you have this written on your paper. Next thing you're going to write is equal 5 antiderivative cosine of x dx. How many knew it? Point 2 for length. Now you just use the rule. We've been emphasizing all year long, equal means these things are the same. Look at this. The pink sheet's super easy because you're just looking for an exact match. That is exactly the same thing as sine of x. Remember the plus c, that's an afterthought. Don't really think of that as part of the formula. That's just a reminder that, oh yeah, there could be a number. So this becomes 5. The orange box becomes sine of x. And then I remember that, oh yeah, I might have an extra 7 or something. I don't know. So that's it. Problem 1 is now done. So. Question? That was all of them. Sorry, I tried to make it easier, but you know.
We can leave that C in the, that's like our answer.
That's done, yeah, that's it.
If you don't have the C's, the problem.
Yeah, you have to have the C because it could be plus 7, it could be plus 0. Gotta have the C. Look up. Okay, I do want you writing the problem. Like I promise, it will help your memory to write the problem. You do not have to write the purple step. I'm totally fine if you go, oh, that's this. Question? Cool. Next one. Please write down number 30. That's why I said we're jumping around, so don't worry about the order. Write down number 30. Your intuition should be helping you at this moment also, because like the constant rule in the multiplying constant rule with derivatives, there's also a similar rule for antiderivatives. There's an addition subtraction rule for derivatives. There's an addition subtraction rule for antiderivatives. So raise your hand and tell me what's the first thing I should do in this case. Just whatever your brain thinks you should do, it's right, I promise. Calvin?
Split up 14 plus 7.
So I write this on my paper, then I write equals antiderivative 4t dt plus antiderivative 7 dt. Just split it apart. Make sure you use the proper notation. You must write the dt. So, question? There were people yesterday on the FRQ test that lost points because they did not write dt. So. Please.
Well, you can have to add like the derivative rule, or
What I was saying is that with derivatives, if you're finding the derivative of 4t plus 7, the first thing you do is split it into two separate derivatives.
Yeah.
Same thing here. You're finding the antiderivative of 4t plus 7, so you split that into two separate antiderivatives. It's 2 points. Yeah. Okay, this is, the 4 is a multiplying constant, so it just tags along. This is t to the first power. So I just look at my pink sheet, I use the power rule. This becomes t to the 1 plus 1 divided by the same. That's it. So far. Question? Please.
You just explained that.
So again, mentally I can think of these completely separate now. So I'm not thinking of that at all. Are you okay that the first thought would be pull out the 4?
Yeah.
So I just kind of set aside the 4 mentally. I don't even think about it. I have t to the first power. So look at your sheet. The rule says x to the n, so it's t to the first. Antiderivative of that is t to the 1 plus 1.
Okay. Yeah.
You see it?
Yes.
2 points. Anybody else? Please.
So after we do that, then we can get rid of the integrals.
Right, because you've applied the rule.
But then why did we not get rid of it for number 1? Or did we? I think
You're okay.
Oh,
On number
we did.
1,
Never mind.
you see it?
Yeah.
No, 2 points. Good question. Anybody else? Please.
You just simplify that?
Like I'll keep going and I'll say, oh, Top's factored, bottom's factored, so I can divide factors. Points for Josh. Question? Okay, the 7, I could teach you a rule, it's not worth it. Watch this. Please just say out loud what goes here. Say it. So watch this. Oops, that's a bad T. Can't live with that. Ah. That's it. If the derivative of 7t is 7, the antiderivative of 7 must be 7t. Oh, good response. You want to talk more about that? So the antiderivative of 7t is just 7. And then I remember that, oh yeah, I could have had some other number, I don't know. Please.
So on our rule it says plus c when we did the 4. Would you need to have plus c with that, or is there only one plus c?
The thing to remember is the plus c really isn't part of the rule. It's just a reminder that, think of it this way, Justin. So I'm going to change color for a reason here. If you have a formula like this, so remember the big picture here. What we're really trying to figure out, oh, that's a T there, I messed up. How many saw the mistake? 2 points. Look here, please. Okay, please raise your hand. Please raise your hand if you can tell me, what do I write here? Come on, hands. What gets written here? Look at it, you can do it. Talk to each other, give me your hands. What goes here? Hands up, come on. Come on. Marin, what is it? Who had their hand raised and was ready to say that? 2 points, 3 for Marin. Look up here. That's all we're doing. We're finding the antiderivative of 4t plus 7. That antiderivative is 2t squared plus 7t. Because if we take the derivative of this, we're right back where we started. 4t plus 7. However, answering Justin's question, could this have been 4t plus 7 plus 5? Yes or no? Come on. Would that be okay? Yeah. Could it be minus 8? Yeah, that's why the C isn't really part of the rule. It's just an afterthought. Does that make sense? Yeah. Yeah, so just at the end, you just say, oh yeah, there could be a number. So answer your question. Perfect.
Quick question. So like on the 7, isn't it like, I'm kind of confused. Like, isn't it dt, not t? Like, is there that difference?
You got to remember what the symbols mean. These two symbols are working together, and they're saying, what is the antiderivative of that? Like, what would you start with, take a derivative, and get that?
Oh, I see.
Well, if I start with 7t, take a derivative, and turn, so look, here's the match. This is a dt because this is a dt.
Yeah.
So if I take the derivative of this, I'm going to get 7.
Yeah, I see.
You good now?
Yeah.
2 points. Good now? Cool. That's it. We're done there. This was just answering a question. Next thing. Go to number 10. Write that down, please. Go. Write down number 10. Cool. Just hands up, what's my first thought? Come on, read my mind. As I look at that, what's my first thing I'm going to do? Rachel?
We separate them.
Okay, everybody look here. Everybody got to see eyes on me. So with addition or subtraction, you just separate them. Never with multiplication or division. Okay? Like there's no such rule, just like derivatives. With derivatives, we had the power rule and the quotient rule, because you can't just separate with division or multiplication. With addition or subtraction, you just separate. Wade, if you need me to talk through that again. So it's the same idea as derivatives, okay? So I'm going to separate and do them separately. The 25 is just a multiplying constant. So this is where you can save time. You don't have to write all the steps, because you've done a lot of that with derivatives. You're good at it now already anyway. So the 25 is just a multiplying constant. So I just write it down. Okay, please raise your hand if you know what comes next. We're going to find the antiderivative of x to the 4th using the power rule. So what gets written next to the negative 25? Negative 25 is just a multiplier, so you just write it down. But now I have to use the power rule to find the antiderivative of x to the 4th. Show me your hands. Come on, talk to each other. Just do it quick. Don't overthink it. What gets written next to the 25? Hands up. Come on. More people know than this. Like, what gets written next to the 25? Lauren?
X to the 5th.
Whoops. Keep going, Lauren. Now what?
Over 5.
Perfect. You look at the board. The negative 25 is a multiplier here. You go to the next line, it's still a multiplier. And then you just find the antiderivative of x to the 4th. But fractions multiply straight across. So this is just things being multiplied. It's easy to handle that, because if things multiply straight across, the order doesn't matter. So I can rearrange this order like this. I wouldn't write this down. I just do this mentally. And I say, oh, that's just negative 5. So I've finished the first part of this antiderivative. Wade, if you need me to talk through that more.
Do you encourage that we do one of them and do the next, or that we do all of them?
It won't really matter once you get a little better at it. Right now it seems to kind of help to focus on one term, and then we'll just move on. So either way, 2 points. Please.
Do we put a plus c after all of these, or just plus c at the end?
I'm going to ask you a question because I hope you can answer it, and then I think it'll make more sense. So what I was saying to Justin, that what we're really trying to do is we're thinking of it as, hey, this whole thing was the derivative of something. So we want to get some sort of equation, right? And then we just want to remember, oh yeah, but we could have started with all of this plus 8.
So it's just be a plus c.
It's just an afterthought. Does that make sense? Yeah. 2 points. Anybody else? Next thing, write down the minus. That's what Elena was saying. This is a pretty good method, just kind of one column at a time. The 3 is just a multiplier, so it doesn't do anything. So what gets written next to the 3? Hands up, come on. Talk to each other and raise your hand. What gets written next to the 3? Hands up, come on. Hoping for a few more hands. Hoping it was easier than the hands were indicating. Julia. Who was prepared to say that? 2 points, 3 for Julia. Now remember, all you have here are things being multiplied, so the order doesn't matter. So the negative 3 and the negative 1 divide to make positive 3. X to the negative 1 is the same thing as 1 over x. So you'll probably see the answer in the back looking like that. If it's the AP test, I stop up here on the FRQ section. There's no need to do anything else. So just stop here. On the multiple choice, you have to go find the answer. And so they might have it like this. So. Anybody else? Cool. So next thing, the 4 is just a multiplier. Same rule. This becomes x to the negative 2 divided by negative 2. That becomes subtraction now. Just don't say anything. Don't tell me about no hopping the fence deal. I hate that rule. Question? Awesome. Next thing. Oh yeah, don't forget the C. I need more time here, just wait. And it's waving, next thing. Warning. I can move the 12 because that's a multiplying constant. It's number 11. A temptation at this moment is to use the 1 over something rule, the ln rule. As I said before, the ln rule does not apply because the pink sheet rules must match exactly. And that pink sheet rule says if you have 1 over x, this ain't no 1 over x. 1 over x is 4. Okay? So I cannot use the ln rule. What I can do is I can do a little algebra and rewrite like this. Now I can use the power rule. And like before, constant just shows up at the end. It's just an afterthought. So. Question? Please, Abby.
Ones where there's multiple things multiplying with each other.
Yeah, we're getting there. Don't worry. It's a good question, Abby. No, really good question. Because you're right. Those you can see they don't fit the rules. Yeah. We just have a couple more like this. So. Anybody else? Cool. This is just a made-up example, but it does illustrate the use of that ln rule. The 5 on the bottom is still just a multiplying constant, because if I separate these like this, it's the same thing. So the 1/5 can come out, and now you can use the ln rule. Question? Cool. Next one. We've already done that. We've done enough of that. It can't be easier than that. So. Question? People still writing, so I'll pause for a minute. Next one. We've done that. We'll skip that. Here we go. It's not exactly what Abby asked, but it really is the same kind of conundrum, the barrier, stumbling block, whatever. Okay. I'm going to switch the video at this point. I'm going to stop this video, and I'm going to make a specific video for number 12. So that I can make kind of different examples in multiple classes, just so you have a few more resources when you're at home to help you get through the homework. Does that make sense? So like the examples you see here, when you get online, you'll see more examples just to help you. So different problems. So let's do that. Sounds so official talking like, we're going to stop the video now. Stop.